All right, in this next lesson, we are going to take a look at polynomial and rational inequalities. So, to start, let's just review a very simple linear inequality. We would treat this just like an equation to start. We want to get x by itself. So, to do that, I would subtract 7 over 3x is greater than negative 2, divide both sides by 3, and we'll say x is greater than negative 2/3. Okay, now the only thing to remember whenever we're dealing with an inequality, if we multiply or divide by a negative number, we would flip the inequality sign, right? So at any point when we're solving this, right, when we're getting the variable by itself, if we have to multiply or divide by a negative number, we would flip the inequality sign. We didn't have to do that here, right? But so this is my answer. X is greater than negative 2/3. Now we are going to express that using interval notation for this section. So I'm saying I want everything larger than negative 2/3, not including negative 2/3. So my solution set is going to be this, negative 2/3 to infinity. All right. So let's then take a look at solving a few polynomial inequalities. All right. So we're going to go through these steps as we do this first example here. The first step is just get everything on one side and then 0 on the other side, just like we would an equation. So if I subtract 2 over, I'm going to have x squared plus 4x minus 12 is less than 0. Right? So then we want to find all the roots of the polynomial, just like we would if it were an equation. So here, this is a quadratic, and I can try to factor this. Right? Sometimes we may have to use quadratic formula, but I think in this case we'll be able to factor. So I want two numbers that multiply to negative 12 that add to positive 4. I think 6 and negative 2 would do that. So this would factor into x plus 6 and x minus 2. So then, if we set each of these factors equal to 0, right, x plus 6 equals 0, and subtract the 6 over, we'll get x equals negative 6. Same here, x minus 2 equals 0, add the 2 over, we'll get x equals 2. So now what I want to do is place those roots on a number line. That's step 3 here. So I'm just going to draw a line and put negative 6 on there and positive 2. So now what I want to do is create a sign chart. I am going to test a number on each of these 3 intervals, right? So basically any number less than negative 6, any number in between negative 6 and 2, and any number greater than 2. And what I mean by test is I'm going to plug that into my equation and see if I get a positive or a negative value. So let's plug in negative 7. Okay, so if I plug negative 7 into this factor, negative 7 plus 6 would be a negative value. Right? If I plug negative 7 in here, negative 7, actually, let me write this out. Do this in a different color. So here we'll have negative 7 plus 6 times negative 7 minus 2. So all I care about is the sign. All I care about is whether it's positive or negative. So this would be a negative value, right? Negative 7 plus 6 is going to be negative. Negative 7 minus 2 is also going to be negative. So, oops. So I have a negative times a negative. That's going to get me a positive value. So I'm just going to put a plus sign here, right? Then I'm going to take a number in between negative 6 and 2. 0 would probably be a good option, right? Whenever we can choose 0 for something like this, choose 0. So if I plug 0 in for x, I'm going to have 0 plus 6 times 0 minus 2. So again, all I care about is the sign. So that would be a positive times a negative. A positive times a negative is going to get me a negative result. Then finally, choose a number greater than 2. And I could choose anything, but I'm going to choose 3. So if I plug 3 in for x, I'm going to have 3 plus 6 times 3 minus 2. And again, all I care about are the signs. So this is going to be positive, and this is going to be positive. So a positive times a positive gets me a positive result. Okay? So what we've created is a sign chart. This tells me the sign of this function on each of these intervals. Now, if I look back at my original inequality, what I'm wanting to see is where this is less than 0. That means I want to know where it's negative. So looking at my sign chart now, I can see that my function is going to be negative on this interval between -6 and 2. That's my answer. My answer is this interval. Okay? So I'll write that out as -6 to 2. That interval is my answer. I'm not including my endpoints because my original problem does not say or equal to. Right? Now, graphically, let me explain what we just did. Okay? This is the parabola x squared, x squared plus 4x minus 12. Okay? So this is x squared plus 4x minus 12. We found the zeros, right? We found these 2 points, -2 and 6. And I said, well, in my original problem, I only care about where this parabola is less than 0, right? Where it's negative. So what we did was we just chose a point to the left of -2. Okay, we chose 3, plugged 3 in, right? And said, well, that's a positive value. So that entire piece of the graph is positive. Then we picked a zero or a value in between -2 and 6. We chose 0 and found that that was a negative value. That means that entire interval is going to be negative. Then we picked a value greater than 6 and said, well, that value is positive, so everything on that interval is positive. So our answer, the points where the function is negative, right, is all of the x values in between -2 and 6. That's why our answer is that interval. And for our answers, the intervals are always going to be x values. Right? Let's do one more polynomial example. Right? So start by getting everything on one side and 0 on the other. So I'm going to subtract the 25x squared over. So I'll have x squared minus 25x squared is greater than or equal to 0. Then find all roots. So in this case, I can start by taking out a GCF. I can take an x squared out of both of these terms, and I would be left with x squared minus 25. Then we have a difference of squares. So this would factor into x plus 5 and x minus 5. So now I have 3 zeros, right? This one would just result in 0. This one would result in -5, and this one would result in +5. So I want to put all 3 of those values on a sign chart. So -5, 0, and 5. And I want to test a number on each of these intervals. In this case, we have 4 intervals. So, and again, all we care about is the sign. We don't care what the actual value is. So if I plug in a number less than -5, say -6, well, -6 squared would be a positive value. -6 plus 5, that would be a negative value. And -6 minus 5 would also be a negative value. So we're going to have a positive times a negative times a negative. That's going to result in a positive since we have 2 negative signs. Plug in a value in between -5 and 0, say -1. So -1 squared is positive. -1 plus 5 would be positive. And -1 minus 5 would be negative. So positive times a negative is going to be negative. Plug in a value between 0 and 5, say 1. So if I plug 1 in, I'll have a positive, and a negative, right? So positive, positive, negative. Multiplying those together would get me a negative. Then finally, choose a number greater than 5. So say 6. 6 squared would be positive. 6 plus 5 would be positive. And 6 minus 5 would be positive. So a positive times a positive times a positive gets me a positive. Now, if I look back here, what I want is for my polynomial to be positive, right? Greater than or equal to 0. So my answers would be this first interval, negative infinity up to negative 5, and also this last interval, 5 to infinity. Now, there is actually, oops, I do want to include negative 5 and 5 this time. I almost messed that up because it is or equal to. Now, with that, okay, with the or equal to 0, at 0, this would be equal to 0 because we found that 0 was a root. What that means is we actually have another part of my answer. Okay? Another part of my answer is just going to be the value of 0. So technically, we should have 0 in here. If we just have a single value that we're including, we usually use curly brackets. Okay, so technically, this would be my answer. And graphically, okay, this is what we're saying. We're saying that the function is positive from negative infinity up to negative 5. Right? It just touches at 0. But since we're saying we want everything that's greater than or equal to 0, we want to include that value. So here, I want to say all the x values here, that single x value, and then all the x values greater than 5. Okay, so graphically, that's what we just did. Now, let's do the same thing, but for rational inequalities. And these are going to be very similar, just one small difference. Right? Now, the first step is, again, to get everything on one side and 0 on the other. So I would subtract 3 here. So we'll say x squared plus 2x minus 15 over x minus 1 minus 3 is greater than or equal to 0. Now, if I have multiple fractions, I want to combine them into a single fraction. That's what we've been working on so far. So I need to get common denominators here. I'm going to multiply this, because we're thinking about this as over 1. So I'm going to multiply this by x minus 1 over x minus 1 to get common denominators. When I do that, right, if I multiply times x minus 1 and x minus 1, I'll have 3x minus 3 in my numerator, and then just x minus 1 in the denominator. And then I can combine my like terms in the numerator. Right? So I would just have x squared, then 2x minus 3x would be minus 1x, and negative 15 minus negative 3 would be negative 15 plus 3, so minus 12 over x minus 1. And then we want to factor anything that we can. Okay? In this case, I could factor the numerator. So that would be two numbers that multiply to negative 12 that add to negative 1. So I think negative 4 and positive 3 would do the trick. So my numerator here would be x minus 4 times x plus 3. And then my denominator is x minus 1. So now, if I look back up at my steps, it says set the numerator and denominator equal to 0 separately. We want to find all the zeros and all the places where the function is undefined. So undefined would be wherever the denominator is 0. So if I set each of these equal to 0, X minus 4 equals 0 would get me x equals 4. X plus 3 equals 0 would get me x equals negative 3. And x minus 1 equals 0 would get me x equals 1. So I want to take all three of these values and put them on a sign chart. Okay? So negative 3, 1, and 4. And I guess I should mention it is important to put these in order, right? So then we've got 4 intervals. I'm just going to take a test value and plug that into my function. And I can choose any version of my function that I've simplified here. So I'm going to go with the factored form. That's going to be easiest. So if we take a number less than negative 3, say negative 4, and plug that in. So I would have negative 4 minus 4 would be negative. Negative 4 plus 3 would be negative. So negative times a negative over negative 4 minus 1 would be negative. So I've got a negative times a negative divided by a negative. That's 3 negative signs. So that means that's going to be a negative. If I plug in a value here, between negative 3 and 1, let's say 0. So 0, that would be a negative, that would be a positive, and that would be a negative. So I've got a negative times a positive divided by a negative. That's 2 negative signs, so that's going to be a positive. If I choose a value between 1 and 4, say 2, 2 minus 4 would be negative, 2 plus 3 would be positive, and 2 minus 1 would be positive. So a negative times a positive divided by a positive is negative, and a value greater than 4, say 5. So 5 minus 4 is positive, 5 plus 3 is positive, and 5 minus 1 is positive. So a positive times a positive divided by a positive is positive. Now I'm doing a lot of these, kind of quickly in my head. If you want to write them out, that is perfectly fine, right? So if you want to write out plugging in 5 into this to see that you get a positive value, please do that, right? Please, if you want to take that step to make sure you're doing it correctly, please do that. So now, if we look at my function here, I want the values that are greater than or equal to 0. So that means that I want the positives on my sign chart. My answer is going to be this interval here and this interval here. So I'm going to say my answer is negative 3 to 1 and 4 to infinity. Now, one small thing that we want to be careful of. Okay, notice that I put brackets around the negative 3 and the 4, but not around the 1. Now, this is or equal to, so we are including our endpoints. However, the value of 1 was what would make this function undefined. That's where we had a 0 in the denominator. So we cannot include that value. We cannot include 1 in this case because that would make the denominator equal to 0. All right? Let's do one final example together here. All right, well, first, let me show you graphically what we did. Okay, we found these zeros here, and then we found that at 1, the function was undefined. Now, we have not talked about graphing rational functions yet. We will at the end of this chapter, okay? But so what we're saying, we wanted everything that was positive. So I took this piece here and this piece here. And when we're describing that, we're just describing the x value. So we said from negative 3 to 1, and we're not including 1 because that's an asymptote. It's a place where the denominator was equal to 0. And then we're saying from, what was that value? From 4 to infinity. Okay. One final example here. Right. Again, first step, get everything on one side and 0 on the other. So I'm going to subtract this over. So I will have x plus 3 over x plus 1 minus x minus 1 over x minus 2, and that would be less than 0. So now I want to combine these into one fraction. To do that, I need common denominators. So I would multiply this fraction by x minus 2 over x minus 2, and I'm going to multiply this fraction by x plus 1 over x plus 1. Right? That's going to get me common denominators. So now let's multiply all this out. In my numerators, I'm going to have, let's see, x squared plus 3x minus 2x minus 6. Now I'm going to leave my denominator factored because I know the goal is going to be to find the zeros, but I'm going to be able to combine like terms in the numerator. So that's why I'm multiplying out the numerators here. Then I'll have x squared, and I know this is going to be plus x minus x, so I'll skip that step. And then we'll have minus 1 over x minus 2 times x plus 1. And that will all still be less than 0. Now I can combine like terms in the numerator. So I've got x squared minus x squared. Those will cancel. Then my x's, I just have 3x minus 2x, so that would just be x. And then negative 6 minus negative 1, so that would be negative 6 plus 1. That would be plus 5. So my numerator ends up just being x plus 5. And then my denominator, which I left factored, was x minus 2 times x plus 1. So now, again, we want to take both the numerator and denominator and set them equal to 0. That'll get me all of my test points that I need on my number line, my sign chart. So this first factor in the numerator, if I set that equal to 0, I would get negative 5. Then in the denominator, if I set these equal to 0, that would be x equals 2. And this one would be x equals negative 1. So I want to take those three values and put them on a number line. So negative 5, negative 1, 2. And I'm going to test a value on each of these intervals to see whether it's positive or negative. So if I choose a value less than negative 5, say negative 6, and plug in to each of my factors, negative 6 plus 5 would be negative 1. And so it's negative. Negative 6 minus 2 would be negative, and negative 6 plus 1 would be negative. So a negative divided by a negative times a negative, 3 negative signs would result in a negative value. A number in between negative 5 and negative 1, let's say negative 2. So if I plug negative 2 in, that'll be a positive. Negative 2 plus 5 would be positive. Over negative 2 minus 2 would be negative. Negative 2 plus 1 would be negative. So a positive over a negative times a negative. 2 negative signs would result in a positive value. Choose a number between negative 1 and 2, say 0. If I plug 0 in, that would be a positive over a negative times a positive. So one negative sign would result in a negative. And then choose a number greater than 2, say 3. All three of these factors would be positive then. 3 plus 5, 3 minus 2, and 3 plus 1. So a positive over a positive times a positive would be positive. For this example, we just wanted the places where this graph was less than 0. So that would be on this interval and this interval. So my answers would be negative infinity up to negative 5. And in this case, I am not including 0. I'm not including the endpoints. So that's going to be a parenthesis. Then we'll union that with this interval, negative 1 to 2. All right. Now, graphically, again, what we just did was we said we want everything less than 0. So I want this entire piece of the graph, okay, and again, we haven't talked about graphing these, but that's what this means, right? This entire piece of the graph ends up being negative. Then this piece over here, all the way up until we cross the x-axis at that point, and we go positive. So I want this entire piece, can't really stay on the line there, and this piece right here up to 5. Right? Those are the places where this graph is less than 0. Right? That is it for this lesson. The final question is going to pop up asking you what questions you have.